most projects, they start simple, but they tend to become complex. So with us here we have Damir Murat from CROZ, who's going to explain us how can we manage that using strategic DDD. So over to you, Damir.
Yeah, thank you. Hello everyone. So, as you heard, I'm Damir Murat. I work as a senior software consultant, if I remember correctly, in IT services company called CROZ. Teams at CROZ, I'm sorry, I will be much nearer to the mic. Teams at CROZ are working with Axon framework for quite some time now. During that period, we had few pretty complex projects, and we certainly had our fair share of issues with them. But as we learned more about the Axon framework and distributed system in general, we were able to handle most of them. But most persisting problems, the most challenging ones, were not so technical in nature. They were more universal. So today I'll talk about one of those universal challenges, and it is a problem of organizing the physical layout for a complex project when you have a large number of modules. So let me try to illustrate the issue. You will see the details in a second. So here I have a project, and here we have a series of screenshots describing evolution of that project over the time. All modules in this project are put directly under the project root. So such kind of project structure is called flat project structure. So as always, things start easy. We have a single module, single deployable unit, all features are implemented inside of it. Things looks nice and simple. But then weird things may happen. Your clients may like it. So you will get probably more features to implement. As those feature requests start coming in, you may realize that some of them are different enough to justify introduction of another application. And this is the moment where things start rolling quickly. For sure, you will notice you have some code to share. And well, good way to do this is to extract it into standalone module and provide that module as a dependency to your applications. If feature requests keep coming in, over the time you will have even more modules to share. And much more quickly than you realize, you may end up with a project containing 40, 50, or even more modules. What you have now is actually a multi-module monster that is very hard to work with. Okay, so what are the issues with the flat project structure? Well, it is very difficult and confusing to navigate because you always have to jump around in pretty much unpredictable manner. And this is because the flat project structure does not suggest anything about relationships between your modules. It does not suggest anything about dependencies, about abstraction levels. Even your system entry points or applications are very hard to find in this structure. It cannot hide anything. It cannot hide things that are irrelevant to your task, to your current task. But probably the biggest problem is that negative usage aspects are getting worse and worse if you continue to add more modules. In general, it requires very high cognitive load, even for the simplest tasks. So how can we solve the problem? Well, the basic idea is relatively simple. We just have to introduce a hierarchy of module categories. But the real question is how to organize that hierarchy and which exactly module categories to use. You may try to organize modules based on their technical similarities only. And that may even work for simpler cases, or if you are building some purely technical solution, let's say administrative interface of some kind. But for business problems, especially for complex ones, the crucial link is missing here, and that is the link to the business itself. So what we are trying to do here is actually to divide complex business domain into smaller, much more manageable parts. and that is exactly the subject of strategic DDD. So now the idea is to leverage three main strategic DDD pillars of bounded context, subdomain, and ubiquitous language to create our solution. And we will call it strategic structure with the obvious reference to strategic DDD. Now I'll describe those pillars, but before I do that, I'll spend a moment with the general idea of a model. So the model is a simplified representation of some real thing or whatever. But the crucial bit here is that simplification is not a random. It should always be directed by model purpose. And the purpose of a model is, of course, to provide a solution to the given business problem. So only with a focus on its purpose, model is able to simplify anything, because without that purpose, it simply does not know which properties should be emphasized and which one should be ignored. So models without the purpose are not really that useful. And that idea about strong connection between model simplification and the purpose is actually implied in DDD. So let's start with subdomains. Those descriptions will be very brief and quick. I guess you know all this stuff. So subdomains are a DDD tool for understanding existing business capabilities and activities. Subdomains are discovered when you are analyzing the business. DDD divides subdomains into three types: core, supporting, and generic. Regarding mutual relationships, subdomains can be peers or they can be nested. And regarding the size, they can be large, medium, or small. All those things, all those aspects, you have to take into account when you are analyzing the business and when you are trying to assign later subdomains to their corresponding bounded contexts. In that strategic structure that we are trying to build, subdomain names will be visible in the hierarchy and also in the names of modules. Ubiquitous language is a DDD tool for effective communication, for gathering and sharing the knowledge. It is the language of the business and it should be precise and consistent. In a way, ubiquitous language is one of the first implementations of your model. You are using it for pretty much simplified conversation with domain experts, and those conversations should be always focused on your problem. You don't want to know everything from the domain, but only things that are relevant to you. So in strategic structure, ubiquitous language will be visible in many places. It will be visible in the hierarchy through the names of bounded context and subdomains. It will be visible in the names of modules. It will be also visible in implementation artifacts like domain model, orchestration logic, APIs, and similar. Single ubiquitous language is valid only inside of its boundaries, and those are in DDD defined by bounded context. So, finding bounded context is one of the main tasks of strategic DDD. Bounded context is a boundary of your model, and it can potentially span across multiple subdomains. So, the bounded context should be designed, and it should be designed, those boundaries should be drawn, again, with a very specific purpose, and that is your problem that you're trying to solve. It is interesting to analyze for a moment the relationship between bounded context and subdomains. So in general, bounded context boundaries may span across multiple subdomains. But there is a common special case which is very convenient, and that is when bounded context boundaries matches one-to-one with a single enclosed subdomain. And if you can use that simplification, you should definitely go with it. In the strategic structure, bounded contexts will be used as a primary way for organizing the modules, and the subdomains will be the second. Okay, let's turn now to the details of strategic structure. So what is it? A strategic structure is a hierarchy of those module categories, and that hierarchy organized around bounded context and subdomains. The goals of strategic structure are almost exact opposite to the properties of flat project structure. So I will not list them all, just to mention the first one because it is kind of important. So strategic structure should provide apparent dependency direction for those module categories, and that direction of dependencies between module categories should consistently go in the top to bottom fashion across the entire structure without any, for all modules, always. It is a pretty much strict property of the strategic structure. The general goal of that structure is that it should significantly reduce the cognitive load that is required for navigation and lookup of your artifacts like classes, resources, and other stuff. But if you think for a moment how frequent that operation is, you may realize that to get even small improvements in those areas may actually bring big benefits. If you are trying to look at the picture, don't, because we will go through the details. Strategic structure starts with only two directories, modules and support. And support is even not the subject of strategic structure. It is a free form and contains important but still supportive artifacts like documentation, scripts, and similar things. The idea behind it is to remove as much stuff as possible from the root project and to place it in a single directory. In contrast, modules directory is the subject of strategic structure, and it organizes all modules that you have in your project according to strategic structure guidelines. I will now slowly describe or introduce that hierarchy of strategic structure. We will say more about the content of those directories in a second. So there are three levels of strategic structure. The first one is a system level, the second one bounded context level, and third one subdomain level. On the system level, we have division into three directories, BC, lib, and the other. BC stands for bounded context, and it is entry point to the second level. The lib stands for system libraries, or modules that are considered to be system level libraries. And then we have that other directory. Well, in there you will have leftovers. You will find there modules that are technically important and significant, but don't have a really strong logical connection with either of your business logic or infrastructural code, but they have to be there. On the second level, for each bounded context that you have in your system, we have a separate directory. So in the example, you may see cargo tracking bounded context. And then each of those directories is further divided into three, ASD, domain model, and lib. ASD stands for a subdomain. Domain model will obviously contain majority of your business logic. And lib directory is for bounded context level libraries. At the third level, for each subdomain inside of its corresponding bounded context, we will again have a separate directory, and each of those will be further divided into APP and lib, where APP stands for subdomain applications and lib for subdomain libraries. So subdomain applications are your system entry points. They're positioned at the top of dependency and abstraction level hierarchy. You may find things like high-level orchestration logic there, or maybe your definition APIs. Idea is to have some relatively high-level stuff in subdomain applications. Subdomain libraries contain subdomain-specific reusable code. Some of modules in that directory may understand your ubiquitous language or your business logic, and the other ones will not. They will contain purely infrastructural code. So at this level, in this directory, we have some kind of mix of modules and concerns. Regarding dependencies, any module from those categories can use anything from lower level module categories, but they cannot use anything from different subdomain or from different bounding context. And it is worth emphasizing again that I think is green arrow in the screen, right? Green arrow going down, it stands for module category dependencies and their direction. And it goes consistently down through the entire system, not only at the third level, but rather to the entire hierarchy. Okay. On the second level, we have a domain model. It must be consistent across corresponding bounding context that also includes all enclosed subdomains. And the interesting fact is that it should be as free of technology as possible and as practical. You will never achieve 100% purity. I think this is impossible. But you can add third-party dependencies in there, but you have to carefully control them. It should never happen that you accidentally add dependency to the domain model. If you have them, then it is very good to control them, and you can enforce this with tests. Regarding bounding context libraries, there are two ways to arrange them. What you see here is a default variant. It consists of a single lib directory, and all modules in there will contain purely infrastructural code, meaning they do not understand anything of your business logic, but they can be, under special cases, controlled cases, they can be used as dependency from a domain model. It is allowed. You shouldn't do it, but it is allowed if you need it. Regarding dependencies, the situation is similar as before. Those modules can use anything from lower level module categories, but they cannot reach into another bounding context for their dependencies. Let's take a look at the second variant of organizing bounded context libraries, and this is when it is necessary to reuse business logic at the level of the bounded context. In that case, you may split the lib directory into two, into blib and ilib. And blib will contain modules that do understand your business logic, while ilib will contain purely infrastructural modules. Why those names exactly, you will see in the demo, actually. So on the first level, we have system level libraries. And there are actually two groups of that kind of modules. In a lack of better name, the first one is called generic system level libraries, and the second one is language extensions. So both of those groups have very high reusability potential, and if they are useful, you may use them even outside of your project. Generic system level libraries deal with things like configuring, extending widely used third-party libraries that are relatively focused and at a relatively low level of abstraction, at least comparing to your business logic. The things like Hibernate, Jackson, and similar, but at the generic level. Not at, you are not creating, for example, Jackson the serializer and serializer for the elements from your domain model, but something like strings or some similar things that are very generic. This is the category for such things. In general, those generic system level libraries should not be used from domain model, but exceptions are allowed if you need them. And we have that language extension category, which is at the lowest level of the both dependency and abstraction hierarchy. And it is interesting to realize that language extensions are actually at the level of your programming language, or JDK. which implies that they can be used from everywhere, including your domain model, in the same way as you can use programming language from any part of your system. Don't look at the pictures, you will see those in the demo. So there is one more important characteristic of strategic structure that is related to the naming. So the main goal here is to maintain a match between direction of dependencies and the alphabetical order of the hierarchy elements. So you can that way have a match between organization of things at some conceptual level, you will see that, with the physical level as it is arranged in the file system. And that may be actually very powerful in certain areas. And another important thing here is that strategic structure is also extended to the packages namespace. So in a way, we have two instances of strategic structure, one of the file system and another one in packages. And that second one can provide you additional very interesting characteristics like sensible, actually useful alternative perspectives at your project layout, where those perspectives are based on packages. So now is the demo time. There are two topics to cover here. The first one is related to the visualizing of dependencies, and the second one is about those alternative perspectives. So for visualizing dependencies, I will use a third-party tool. It is called Structure 101. What you see here is a default view. I know it is small, but the tool doesn't have a zoom, what to say. But it works nice in the areas for which it is specialized. So I have all modules from the project, and they are already organized in some kind of hierarchy. And that hierarchy is based on mutual dependencies between modules and the number of those dependencies at bytecode level. So every dependency you will see here is coming directly from the code, meaning no fakes of any kind here. Okay, as I'm clicking on modules, you should be able to see blue arrows coming in and out. So those are dependencies, both inbound and outbound. The essential property of this tool and all other similar tools that I saw is that what is considered correct direction of dependencies will always go down, always. In contrast, illegal dependency will be reversed, it will go up. But what we are really looking here is a way to express our own perspective on the architecture in terms of those dependencies between module categories. We would like to have high-level architectural skeleton of strategic structure that includes all elements, each level of the hierarchy, every module category, and even individual modules. So there is another view where you can create your own architectural perspectives. It is called architecture diagrams. And what you see here is the architectural skeleton of strategic structure. You may see levels of the hierarchy. Here is, for example, bounded context level. Do you see that? Okay, then subdomain level. Here is the system level. You may see even in module categories, for example, subdomain applications, subdomain libraries, domain model is here, and so on. Then you may even expand a single module category and see dependencies on the level of individual modules. Very nice tool, especially when you have to untangle some dependencies in your system. As I'm clicking through that hierarchy, you will notice that all dependencies are consistently going down, no matter where I click inside of this model. So what we have here is conceptual model of that strategic structure. And there is another important but little bit hidden property, and that is that that direction of dependencies between modules actually usually is aligned with direction of abstractions. This means if you are looking for higher level abstractions, you will probably look somewhere at the top of this conceptual model. If you are looking for more details, you will go a little bit down. Let's say for business logic details, you will take a look inside of the domain model. And if you are looking for, let's say, implementation details of some low-level function, you will move even further down, maybe to the level of those language extensions. So we have a match between direction of dependencies and direction of abstraction levels, which is actually very powerful because now you have two strong hints where you should go in your project when you're looking for things. If you are looking for some higher level abstractions, you will move up. If you look for more details, you will move down or go down. I have an example for that. It is a bit abstract, but you will see it much more concretely in a second when we move to IDE. Let's imagine that we are working with Axon application and that I have to look at the details of some use case. I will probably start exploring at the level of orchestration business logic. And that may be implemented in a form of application service or application facade. Such thing in this structure will probably be positioned somewhere in subdomain applications. But the details of orchestration logic will not be enough. I'll have to take a peek also in the exact details of domain logic or exact details of business logic, and for those, I will probably look at the domain model. If it is Axon application, then business logic will be implemented probably in a form of aggregate and maybe value objects. And if I'm already examining aggregate, I will probably want to have its inputs and outputs. I will probably have to look at those also, meaning in commands and events. And finally, if I have to look for details of implementations for some low-level functions, I may go even further down. But we are in specialized tool, and you didn't see any of the things that I just said. So we will move to IDE. And we will look how strategic structure at the physical level stands with that desired direction of dependencies and abstractions. Okay, I'll start exploring the structure at the modules directory, and I will completely ignore that other directory. It is not relevant for the moment. So I'm selecting the BC and lib directory. And now it is on the right, yeah. And now take a look at the architectural skeleton diagram of our system. And you will find that BC corresponds to the bounded context, and the bounded context is at the top. And the system level, which corresponds to that lib directory, is on the bottom. So at this level, at least, I have a match between direction of dependencies and the physical order of directories at the file system. Okay, let's expand to the level of bounded context. And I'll select some directories. Then again, take a look at the picture. At the top, I have subdomains. Here it is. I'll try to mark it. I can, but I guess you see something. Okay, right beneath it, we have a domain model the same way as at the directory level. Then bounded context libraries, and finally system libraries. And again, I have a match between conceptual directions in the model and the physical directions at the file system. So I can navigate through the code in the same way as I imagined in the model. And desire to keep that directions, to always match them, is the reason why there are some oddly looking names in that hierarchy. This is the reason why I have A in front of ASD for this module category, because if I name it just subdomain model, it will be lost, and I won't have any longer match between conceptual directions and those at the file system level. Okay, it works in the same way for the rest of the hierarchy. Now, I'll try to find those artifacts that I described, that I mentioned previously. So for application facade, I will pick one of subdomain applications to try to find it there. Since I will also try to find the aggregate, it makes sense that I'll pick command side application. So somewhere inside, I should be able to find something that implements high-level orchestration logic. That is the idea. Here is our application service. And now I try to find details of the business logic. For that purpose, I'll move down to the level of domain model category. And somewhere inside, I should be able to find the aggregate. Here it is. And the command and event. Okay, I'll also mention some low-level utility or function, and for that I will move even further down to the level of system libraries, and somewhere inside I should be able to find some low-level utility class containing appropriate functions. Here is one that deals with timestamps. Okay, so it looks like that strategic structure on the physical level maintains the match with the conceptual and desired orientation of dependencies and abstraction levels in that model. But let's now turn attention to the second topic of the demo, to those alternative perspectives. What we are looking here on the left is actually the default way in which IntelliJ IDEA represents your project. We have a mixture of different hints here. For example, we see the elements of the file system, but we also see the packages. And this is probably the way you are used to look at your project. But remember that I said the strategic structure is also extended to the packages namespace, and it should work in the same way as at the physical level of the file system. So I'm expecting that I can use a much more compact view to work with the project, and that may be especially useful for complex projects. If you have that packages namespace organized in a sensible way that actually tells you something, then you may look at some alternative perspectives on your stuff. So let's choose the packages view, and I'll start exploring strategic structure again. And I will try to find first application service. Here it is. And I'll move down to the domain model. Here's the aggregate. Then a command. I'm looking for command and for event. Okay, you can immediately see that this view is much more compact than a default project view, and this is okay. But now we have also different stuff in there, those green things, which are tests. Depending on your background, you may even feel that this is a very good thing, and you are right. This is the way as at the front end, tests and your production code are usually arranged. On the back end, there is some different history, so we have different source sets for test and production code. Anyway, there is a desire to have a feature which will provide filtering capabilities on your packages namespace. Unfortunate truth is that such feature does not exist for packages view. But IDEA provides an alternative feature that is called custom scopes if you want to filter elements from your project. And this is really, really useful feature with enormous potential, because you can define different file sets that are very specific to your tasks. For example, if you have multiple abundant contexts in your projects, you can create corresponding custom scopes that includes only files from each bounded context, and you may work with a focus on those things only. We will explore now that first scope that I have defined here that will include all production code, meaning without tests, from this project. And again, I'll try to look for the same things I did before. Here is application service. Then in the main model, I will try to find the aggregate, a command, and event. Okay, and this view looks much better than default project view because we removed some stuff. We have filtering capabilities applied here. But again, there are elements of the file system and packages combined in this view. So we would like to have combination of packages view and custom scopes. We would like to have custom scopes for their filtering capabilities and packages view for its compactness. And you cannot have it because that feature does not exist in IntelliJ IDEA yet. So I cannot demonstrate what I believe would be the most compact but still comprehensive perspective on your project that may be especially useful if you are working with really complex projects with a large number of modules. But there is a hope, and now we are talking about that link down below. So if you think that combination of packages view and custom scopes is a useful feature, here is a feature request behind that link, and if you can spare a bit of time, please vote for it. That certainly will improve our chances to have that feature in the future. Okay, let's move on. Strategic structure is not set in stone. It can be adapted, it can be simplified, and this is much easier to do if you know how fully expanded structure works and how it looks like. Here is the simplification for that common specific case when we have a match between single bounded context and one enclosed subdomain, which is relatively common in practice. So from 3 elements of the hierarchy, we ended up with only 2. You have also the refactoring steps necessary to achieve the example from the picture. And having 2 levels of the hierarchy instead of 3 is, of course, very, very significant simplification, and you should definitely use it if you can get away with it. I mean, if you can use one-to-one match between bounded context and subdomains. Okay, until this point, I said a lot of guidelines, rules, and regularities around strategic structure. If you take those, you may interpret them as I think I already used the term, as architectural skeleton of your system. But this time, that skeleton implies a set of rules, which includes those things that I already said in presentation. And if you want to introduce a bit more formalism in the strategic structure and their corresponding architectural skeleton, you may implement them in the form of tests. This is a great way to remove probably significant burden from your team, because now they have tests to rely on that they will not break anything regarding your structure or architecture. And a good way to do this is to use ArcUnit library. I have a slide with all the rules, and now we'll go through them one by one. No, we don't. Just for the reference. Okay. Examples I show are coming from the real project. It is called Clockwork. It is open source project sponsored by CROZ. We created it because we want to have the place where we can put and codify and even document some practices from our previous projects. It is also a nice playground for experiments, for observing the results and see if they're useful or not. Clockwork is not a framework, so don't try to use it that way. It is a runnable example of a complex distributed systems and system and applications you can find in there are based typically on Axon framework. It contains a lot of features. It is not only about strategic structure, although strategic structure is the important one. And if you're interested, you can go to the homepage. I think there is enough documentation to help you with orientation. So you can quickly see if there is something that interests you, really. Regarding strategic structure, there are in Clockwork 2 articles that provide some additional details around some corner cases and similar things. And of course, the good way, once you know the basics, is to check out the code and start exploring. The idea is that main branch is always in the working state, so there is no reason to wait for releases. It is not a framework after all. Okay, very brief summary. I'll mention just the last points. So strategic structure is definitely not a silver bullet. It can be useful under the right circumstances, and it may even be necessary if your project strikes the right amount of complexity. You may embrace it entirely, use it in a full shape, or just use as a source of ideas or just some kind of information where you may go or you should go if that complexity strikes you. Anyway, whatever you do, there are some benefits that you may expect. For example, support for much smoother project growth, where you should not be in fear anymore to add additional modules in your system. It should not increase complexity significantly. Additional thing is that it should significantly reduce require cognitive load for frequent operations of looking up things, and those things taken together should bring back some development speed in day-to-day work with the complex project. And this is everything I had. Thank you very much for listening.
Thank you, Damir. And we do actually have a couple of questions. I'll start with the app and then we'll see if there's any in the room as well. So first off, what are the signs I should monitor to assess if my project becomes large and avoid early optimization and keep my system lean at early phases?
Yeah, signs to monitor when you know when your project is large. I will say that probably the best criteria is when you start thinking if you will add additional module or not. I think this is a relatively good point. You will not consider at all if you should add the new module if you know there is some kind of logical reason to add it. But if you have those reasons, start thinking whether should I add it or not, then you are in a complex situation. Okay, I'll not mention at this point some of my experiences, but we can leave them for the entire for the rest of the day.
All right, thank you. And now I'll move on to the next. So at some point, wouldn't splitting the project into multiple projects also make things easier?
Yeah.
Or regrouping multiple modules in a single one?
Regrouping multiple modules in a single one.
The screen is right back.
Okay, we don't need it. For that last one, I don't know really, because I have usually the tendency to split one in multiple ones for some reasons. Like if I have different clients to use them, if I use different third-party dependencies, especially if I have different functionalities inside of it. But I guess if I don't have any of those, I can then bring it back in a single module. And the first part was?
The first part was, bear with me for a second. So at some point, when splitting the project into multiple projects, also make things easier.
Yeah, it does actually. In one of my previous projects, when things are becoming completely unbearable, we just set the bunch of low-level modules and split them in a different project. But I think the reasons were wrong. We were doing that because we couldn't bear that complexity anymore. We couldn't breathe anymore because we couldn't find the things that has to be done. And that was a last resort. I think the project at that point had 90 modules, and that we pick up somewhere around 30 or 40 and just move it away, so that we have a smaller number of modules to work with. But let's say you are using strategic structure, you can, in that case, pick your own timing, and you are completely free to move those modules away, for example, something from lower levels, and use them as third-party dependencies from other projects in your company. That there is nothing that stops you from doing that. But now you will do this for right reasons. You have, I don't know, maybe a different team that will manage those generic functionalities. It is okay for you to remove some stuff out of the way because your team that dealing with that project or boundary context is not anymore responsible for that, and similar things. The point is that in that case, you are controlling when you want to do this, and you don't have to do it just because you want to breathe, actually.
All right, thank you. So those are the questions from that. Are there any from the room? If not, then thanks for attending, and especially Damir, thank you very much for your great talk.
I'll remove all the things now.
Yeah, you can.